Alright, this time we would find the derivative of the function fx is equal to sine x, and that is the sine function. We know that its graph is represented as this wavy curve, and the maximum value it takes is 1, minimum it takes is -1, and basically this is the period or the wavelength of the function. Now, for finding the derivative of x, that is, we need to find d by dx of fx. This actually is an operation on the function x, so we present it like this. So this is the same thing as saying d by dx of sine of x, or d by dx, that is d of sine x by dx. Alright, so for this I need every one of us to know one thing, that the value of this limit, that is sine of h by h. Now this is kind of a prerequisite for finding the derivative of sine x, and it is basically this, that this ratio, that is the ratio of sine of some angle divided by that specific angle, when that angle goes to 0 or is very small but not actually 0, actually turns out to be 1. Now how did that come? I have a graphical explanation for the same, and it is actually this. If I suppose enlarge the sine x function in this manner, and I draw a straight line which is equal to y is equal to x, then I compare both of them. So if I'm calculating sine of some value by that value, I'm actually calculating this. I'm not considering that h is small, first of all, so I'm not considering this right now. I'll only consider this specific ratio, right? So say for a value x sub 0, this y value is equal to sine of x sub 0, and this value is actually x sub 0 because y is equal to x sub 0. So I'm actually calculating this length divided by this length. Obviously sine of that value right now at this specific x prime is x sub 0 is smaller than x sub 0, that is, this height is smaller than this, so the ratio would be less than 1. That's what I can say. But then I make this x prime smaller, so I bring it closer to 0. At that point I go up to this and I divide this by that. Alright, so even though this is still bigger and this is still smaller, that is sine x is smaller and x is bigger, but this value approaches sine of x, that is x almost tends to become sine of x for a very small angle. That is to say, sine of a small angle approaches x when x is small. Alright, so that is to say, when these two values almost become equal, because you see the difference in them starts decreasing, and ultimately the almost and almost become equal to each other. So whenever we divide two quantities who both of which have the same value, then we obviously get the ratio to be 1, and that is why this limit does exist and this is equal to 1. Now, to find the derivative of sine of x, I actually have to write this, that d by dx of sine of x is actually equal to sine of x plus h minus sine of x by h. Alright, now I need to use a specific formula to evaluate this, but I have to write this too, that h is very small. That is why the difference is small and h is small. Remember, this is not a specific slope. This is giving a generalized slope, and we can put any value of x and we can get a specific slope out of this. Now, we need to know what is sine A minus sine B. sinA minus sinB happens to be, using your trigonometric rule, sine of a minus b over 2 multiplied by cosine of a plus b over 2. Alright, and this is the formula. So the derivative, or I should write f prime of x, which is equal to d by dx of sine of x, is actually equal to limit when h tends to 0. This value will become sine of the difference, that is x plus h minus x over 2 multiplied by cosine of the sum, that is x plus h plus x over 2 whole divided by h. Now this cancels out this for any value of x, so there is no restriction for that operation. Now this ends up with sine of h cosine of h plus 2x by 2, this is h by 2, by h. Alright, now this gives me limit h goes to 0 and sine of h over 2 by h multiplied by cosine of h plus 2x over 2. Alright, and now I have to use this limit again, but remember x or h and h, they were the same thing, so even if this is h by 2, I have to make this h by 2. So I multiplied by this, divided by 2 and multiplied by 2 in the numerator. Oh, I'm so sorry, I missed out something. It actually has to be 2 times of this, 2 times of this, so 2 times of this, 2 times of this. Alright, so even if I do this now, that gives me, this cancels out this, and gives me sine of h over 2 by h over 2. I can write this h by 2 goes to 0. Why? Because when h is really small, half of that small value is even smaller, so it goes to 0 even more quickly. And that would be a better approximation. Now limit h tends to 0 to x 2. Alright, this gives me the value as 1. This is 1 multiplied by this. Now I can always check what this limit goes and approaches at when I simply put h to be 0, because that will give me 0 plus 2x divided by 2, that is equal to 2x divided by 2, that is equal to, missed out here, this is equal to cosine of this angle, which is cosine of x. So I actually end up with cosine of x. That is, therefore, the derivative of this happens to be cosine of x. That is, sine x becomes cosine of x on differentiation.